In this video, I want to talk about Part D of Lab 23, a ferric chloride test. So ferric chloride is iron 3 chloride, okay? So it has this iron plus 3 cation in the solution. And what you're going to see, again, it's a really short video. It's a very dramatic color change. It's kind of surprising just how noticeable this is. This ferric chloride solution is usually it's kind of a rust color, really. And if it mixes with any kind of normal alcohol, it just stays kind of this brown, yellow, rusty color. But with phenol, it does something pretty dramatic. And I'll just go ahead and write this reaction out. I'll just say not on test. So again, that ion by itself, it looks like rust. And what will happen is that 6 of these phenol compounds will actually bind up with this ferric ion. And I won't write out the complete structure, just do this kind of shorthand here. Still takes on it'll take on a -3 charge there plus 6 protons. When the hydrogen gets kicked off here, it forms what we call the phenoxide ion, and there's 6 of them in this complex. That's why this gets a total of -6. And then when those 6 protons get kicked off, then it's floating around in solution now. But this forms a very dramatic color change, and you'll see it. I'll say purple. It's really more of a black purple. And all you're doing is recording it. And if you see that black purple solution, then it's a way to test whether phenol is present. If you look at the Wikipedia site for this ferric chloride test for phenols, you'll see a variety of uses in a way. I mean, there's a couple medical uses. One, if a person has an excess of aspirin in their system, it'll come out in their urine. And so you can use this test to determine whether there's like an aspirin overdose for the person. There's a phenol group on the aspirin molecule. So this kind of reaction works not just with phenol, but anytime you have that structure on an aromatic compound. So aspirin has one other thing poking off of it, I think, in this 3rd position. This part of the lecture is much longer than the actual video. In this video, I want to discuss Part E, Lab 23. And it's all dealing with the unknown. And don't worry about there's just one unknown anyway in this reaction. And so, as you were watching and recording information for parts B, C, and D for this lab, then you should have collected this information along the way. And then you'll re-record the test results, and then you can write your conclusions out. Now, I'll say the unknown is one of the samples that we have been using. So based on the combination of test results, then you should be able to identify what the compound is. In the situation, if the test results match up with like 2 of the compounds, then, write both compounds if needed. In the conclusions column, really what we're looking for here is that, like as an example, let's say the unknown showed let's say it stayed orange. Well, if the observation is it stayed orange, then that means the conclusion is that it would be a tertiary alcohol. And so what it's trying to get at is, based on your conclusion just for that one line, based on your test results just for that one observation, what could be your conclusions? If an alcohol is soluble, you can't narrow down a specific alcohol. The best you can say is that the carbon chain is 1 to 4 carbons. So this is really what we're looking for here in the conclusion section. Alternatively, if you want to write down all the alcohols that are possible, of the samples that we listed, you can do that too. But it's really looking for a general observation about what does that test result mean. Okay, thanks.